You spend your entire day operating in this world of, well, just absolute binary precision.
Right, completely controlled.
Exactly. I mean, you write a script, you execute the code, and if the syntax is flawless, the machine does exactly what you told it to do. Every variable is contained.
Every function is totally predictable.
Yeah, and when a system fails, it leaves a log file pointing directly to the broken logic, clean.
Which creates this false sense of omnipotence, honestly. We get so used to these digital environments where we control the physics, the time constraints, the entire architecture.
We play God, basically.
Pretty much. And we forget what it feels like to operate without that God mode toggle.
Right. And then you step away from the keyboard, you walk into your living room, and you just stare at a glass box filled with water, rocks, and living, breathing organisms.
A completely different world.
Yeah. You cross this border from predictable digital logic into the messy, chaotic, wet world of pure biology. And suddenly all that control just evaporates.
Because you can't patch a biological organism with a software update over Wi-Fi.
God, I wish you could sometime.
I know, right? But a biological environment is the ultimate uncontrolled, dynamic system. It's full of these hidden variables that are constantly interacting in ways you just can't perfectly predict.
Which is exactly why we are pulling apart this truly fascinating collision of those two worlds today.
Yeah.
Welcome to the deep dive, by the way. Our mission today is looking at how a highly systematic, engineering-oriented mind tackles a brutal problem of pure nature.
It's such an interesting case study.
It really is. Our source for this is a single blog post. It's from March 19th, 2026, on a site called kianmeng.org. And the author, who goes by Ang, introduces himself with this very specific phrase. He says he's an old software plumber.
It's a very humble title, but it masks a deeply analytical worldview. We're going to observe a complex, feeling biological system entirely through the lens of hardcore software engineering principles.
Yeah, and to even comprehend what is going wrong inside this particular such tank, we need to first understand the architecture of the mind observing it,
Absolutely. The context is everything.
Because the sheer scale of Ang's documentation is just, it's difficult to wrap your head around. The post we are examining is titled Notes on Fishkeeping, Part 211.
Part 211.
Yes, 211.
And the archive as a whole is staggering. I mean, in the years 2024 and 2025 alone, the site catalogs over 730 posts a year.
Which is 2 posts a day, every single day, and across a wildly diverse set of disciplines, too. Like if you look at just the archives for March 2026, he is publishing Notes on Gardening, Part 841.
Right.
And he's writing notes on Haskell programming, notes on dieting, photography, networking, home improvement. And he is deep into these concurrent programming languages like Elixir and Erlang.
And those specific programming languages are actually incredibly telling here.
Oh, really? How so?
Well, Erlang and Elixir, they're designed for building massive, scalable, highly concurrent systems. Think like telecommunications networks.
Okay.
Places where thousands of processes are running at the exact same time. And the core philosophy of those languages is fault tolerance.
Fault tolerance. Okay, break that down for me.
It means they are built with the assumption that individual components will fail. It's inevitable. So the system itself has to be designed to survive and recover without crashing the whole network.
Oh, wow. That is a brilliant lens to look through because, this isn't just a casual hobbyist taking a picture of a nice tomato on a Sunday afternoon.
Not at all.
He is actively linking to his GitHub, but the blog itself is functioning as like a version control system for his physical reality.
Exactly. He treats his analog life as a series of iterative projects governed by FLOSS principles. That's free Libra and open source software.
Right, the open source ethos.
Yeah, which relies on radical transparency, relentless iteration, and exhaustive documentation. You encounter a bug, you document the environment that caused the bug, you propose a solution, and then you publish the results so the broader community can learn.
Okay, but I have to ask about the translation layer here, because Ang lists his support for the Tor project, the Electronic Frontier Foundation, the Free Software Foundation.
All groups dedicated to digital privacy and open internet architecture.
Right. So how does a hardcore digital tinkerer mindset actually apply to a biological hobby? It just seems like forcing a square peg into a round hole.
Well, the methodology is completely agnostic. He's observing the physical world the exact same way a senior developer debugs a legacy codebase.
Yeah.
When he writes Notes on Gardening, Part 841, he isn't journaling about his feelings toward a fern.
Right, it's not a diary.
No, he's logging data. He's creating a historical record of variables: soil acidity, sunlight exposure, ambient temperature, watering frequency.
So when a plant eventually fails, he doesn't just throw it out.
Exactly. He looks back at the code of his garden to isolate the variable that caused the failure.
He is literally debugging his garden.
And he is debugging his fish tank. Which brings us to the specific catastrophic system failure he documents in Part 211.
Yes, the Golden Mbuna conundrum. So the subjects of this post are a pair of African cichlids, scientifically known as Melanochromis auratus.
Right.
And Ang notes immediately that despite being relatively small, they carry a notorious reputation in the aquarium world. They are widely considered to be among the most aggressive, violent fish a hobbyist can keep.
And to understand the nature of this bug, we really need to look at the evolutionary hardware of the Golden Mbuna.
Okay, lay it on me.
These fish originate from Lake Malawi in East Africa, specifically along the rocky shorelines. And in that environment, they survive by scraping algae off rocks.
Just scraping algae. Sounds peaceful enough.
You'd think so, but high-quality algae patches are incredibly scarce. So evolution has hard-coded them to be hyper-territorial. They will violently defend their specific rock against any intruder because losing their territory literally means starving to death.
Ah, so the aggression isn't malice, it's just a raw survival mechanism.
Exactly.
But the problem Ang is logging is that keeping just two of them together in a closed tank is what he calls a recipe for disaster.
Right.
The dominant fish, which he suspects is the male, is just relentlessly harassing the subordinate fish. It's constant physical aggression, particularly during mating attempts.
Which means the subordinate fish is trapped in this state of perpetual physiological stress.
And stress in fish is a big deal, right?
A massive deal. In fish, severe stress triggers the release of cortisol, which suppresses their immune system, degrades their protective slime coat, and eventually leads to organ failure or death from secondary infections.
Assuming the physical trauma doesn't kill them first.
For say.
You know, this dynamic fascinates me because it completely upends conventional human logic. Like, when we encounter a volatile or aggressive element, our first instinct is quarantine.
Segregation.
Right.
Yeah.
If you have a highly reactive chemical, you isolate it. If two kids are fighting in a classroom, you separate them. We instinctively believe that reducing the number of variables in a system automatically increases safety.
We equate isolation with control.
Yes, but in this closed aquarium, isolation is the exact thing causing the failure. It's like locking someone in a small room with a hyper-aggressive roommate.
There's nowhere to hide.
Nowhere to retreat. And every ounce of that evolved, hard-coded aggression is laser-focused on a single target. So why do hobbyists even attempt to keep aggressive elements in pairs like this? It just seems like isolating them concentrates the kinetic energy into a lethal dose.
It does. It's a fundamental misunderstanding of network topology, really.
Network topology. Okay, how so?
Well, when you place two highly reactive elements in a closed loop, you aren't mitigating danger. You are guaranteeing a high-velocity collision. From a systems architecture standpoint, Ang is observing the catastrophic failure of a two-node system.
Okay, walk me through the mechanics of a two-node system failure. How does that map to the fish?
Imagine a computer network consisting of only one server and one client. In a one-to-one ratio, you have created a single point of failure.
Okay, I'm following.
The dominant fish, the server, is outputting 100% of its territorial aggressive energy. And because there is only one other node on the network, the subordinate fish, it's forced to absorb 100% of that energy.
It takes the full brunt of it.
Right. The architecture lacks diffusion. There are no other nodes to intercept the traffic and no firewalls to block the signal.
So the tank environment is structurally compromised from the moment the fish are introduced.
Exactly. And the physical size of the tank is almost irrelevant in a two-node dynamic.
Really? Even in a huge tank?
Even in a huge tank. If there is a direct, unbroken line of sight, the dominant Mbuna will claim the entire visible area as its territory. The system will inevitably crash.
And the subordinate fish will die.
Yes. The bug in this scenario is not the aggression of the fish. The bug is the one-to-one architecture of the environment.
Wow. And this is where Ang's background as a software plumber truly shines. Because, you know, an amateur hobbyist might try to intervene directly.
Oh, they try all sorts of things.
Right, like maybe rearranging the tank once a day to confuse the fish or trying to separate them with a plastic divider. They try to alter the nature of the fish itself. But Aang doesn't waste a single calorie trying to make the Golden Mbuna nicer.
Because you cannot rewrite the DNA of a biological organism. The territorial drive is hard-coded into the Mbuna's firmware.
Firmware, I love that.
Trying to train a cichlid to be peaceful is like trying to train a calculator to write poetry. It's just not going to happen. You have to work within the parameters of the existing code.
Which leads to a solution that at first glance honestly sounds like absolute madness to me. Aang outlines this two-step engineering fix to manage the aggression. His first step, based on his research, is to establish a colony using what's called a harem ratio.
Yes, a critical structural shift. Ideally, 1 male to 5 or more females.
See, I really struggled with the logic here initially. You have a fish that is systematically destroying its only tank mate through sheer violence.
Right.
And the proposed solution is to go to the pet store, purchase 4 more of these hyper-aggressive fish, and drop them into the exact same tank. How does adding more violence to a violent system not just result in a larger bloodbath?
Because it is a brilliant application of load balancing.
Load balancing. That is exactly the phrase that came to my mind. When a massive website receives a sudden spike in traffic, the system administrators don't just sit there hoping their one primary server can handle the load.
Right, because that single server will buckle and crash under the focused weight of all those incoming requests. So they distribute the traffic, they route the incoming requests across a cluster of multiple servers.
So Aang is essentially spinning up new servers to handle the traffic of this aggressive male.
He is deploying social engineering to fundamentally alter the math of the tank. By moving from a 1-to-1 ratio to a 1-to-5 harem ratio, he mathematically disperses the kinetic energy.
So it's about the distribution of force.
Precisely. If the male Mbuna generates, say, 100 units of aggression per hour, the single subordinate female is no longer taking the full brunt of that force. The aggression is distributed. Each of the 5 females now absorbs only 20 units of aggression.
It dilutes the focus. The male tries to chase one female, gets distracted by another, pivots to a third, and in the process, no single fish sustains enough continuous stress to trigger that lethal cortisol cascade you mentioned earlier.
Exactly. It is still a very high-energy environment, but it is no longer a fatal one. The system reaches a state of sustainable tension.
Sustainable tension, that's a great way to put it.
But Aang doesn't stop at social engineering. He implements a second, equally critical step. Environmental engineering. He adds several more artificial caves to the tank.
Physical firewalls for the network.
Exactly. In the evolutionary biology of Lake Malawi cichlids, line of sight is the primary trigger for territorial defense.
Okay, so if they can see it, they own it.
Right. If a dominant Mbuna can visually survey the entire tank from a single vantage point, its firmware dictates that it must defend that entire visible area. So by strategically dropping artificial caves into the tank, Aang is intentionally designing physical blind spots.
He's breaking the line of sight.
He is fracturing the visual field. The dominant fish can no longer see the entire environment at once. This forces the fish to constantly patrol and reset its territorial boundaries.
Oh, which burns up its energy.
Exactly. It burns up a massive amount of its daily energy budget, simply navigating the complex architecture of the tank, rather than using that energy to harass the subordinate fish.
That's incredible.
Plus, it provides the females with complex escape routes. It allows them to break visual contact and immediately drop their stress levels.
You know, the elegance of this solution is that Aang has entirely abandoned the concept of a utopian, peaceful aquarium.
He has.
He just accepts that a zero-conflict state is impossible given the hardware he's working with. Instead, he optimizes the environment to tolerate the bug. He builds a system that can gracefully handle the failure without completely crashing.
And that concept of fault tolerance in telecommunications maps perfectly onto biological husbandry.
It really does.
Sometimes a feature that causes immense friction just cannot be deprecated because it is foundational to the entity itself. The only path forward is to architect an environment robust enough to absorb the friction.
And I want to pivot here because the methodology Aang is documenting extends far beyond the glass walls of his aquarium. This is where a deep dive into an old software plumber's blog actually becomes a masterclass in navigating daily human friction.
Definitely. Now, Aang maintains a strict disclaimer on his site, insisting his posts are for informational purposes only, and that he is merely tinkering.
Right, he's very modest.
Very. But the systems thinking framework underlying his tinkering is a profoundly effective tool for untangling complex personal and professional bottlenecks.
Absolutely. I mean, think about the intractable problems in your own workflow right now. The elements of your life that act exactly like a Golden Mbuna.
We all have them.
We do. It might be a fundamentally chaotic project at work that constantly threatens to derail your week. Or maybe it's a client whose default mode of communication is hyper-demanding and aggressive. Or just a daily operational bottleneck in your business that simply refuses to run smoothly.
And the default human response to these intractable problems is to try and change the nature of the problem itself. We expend massive amounts of psychological energy attempting to patch the unpatchable.
We send endless emails trying to convince the aggressive client to just be reasonable. Or we try to force a chaotic, multi-department project to operate like a simple linear task. We trap ourselves in a one-on-one dynamic with the stressor, standing directly in the line of fire, taking 100% of that friction directly on the chin.
And just like the subordinate fish in a two-node system, the human body can only process that level of concentrated cortisol for so long before the biological hardware begins to fail.
Burnout.
Exactly. Burnout is simply the human equivalent of a system crash caused by an unmanaged, localized load.
So if you cannot rewrite the DNA of the client and you cannot delete the chaotic projects from your workflow, you have to stop trying to change the fish and start changing the tank.
That's the takeaway.
Right. How do you load balance your professional stress?
You alter the ratio of the network. If a single demanding client is overwhelming you, introducing a shared inbox or pulling two other colleagues into the communication loop immediately disperses the point of contact.
Oh, that makes so much sense.
The client is still demanding, but the demands are now distributed across 3 nodes instead of 1. No single person takes the full brunt of the localized aggression.
You change the social engineering. But you also have to implement the environmental engineering. How do you build artificial caves into your daily routine?
You construct physical and digital firewalls to break the line of sight with your stressors.
Like turning off Slack notifications at 6 p.m.
Yes.
Or removing your work email from your personal phone.
Yeah.
Creating a dedicated workspace in your home that you can physically close the door on when the day is done.
Because if you constantly have a clear line of sight to the source of your anxiety, your brain will constantly try to defend that territory.
You'll just burn all your energy patrolling a digital landscape instead of actually resting.
Exactly. The conceptual leap is moving away from the role of a victim trapped in a hostile environment and stepping into the role of the systems architect.
I love that.
An old software plumber doesn't sit in front of his monitor and yell at a server for crashing under a heavy load. He analyzes the traffic, identifies the bottleneck, and redesigns the architecture to route the data more efficiently.
And doing that requires the exact same dispassionate analytical observation that Ang applies to his 841 posts on gardening. You have to be willing to log the failures in your own life, not as personal defeats, but as raw data.
Right. It's just data.
You document the crash, you identify the environmental variables that led to the stress, and you deploy a structural fix.
It requires treating your own life as an iterative open source project. You don't aim for a final perfect state of being. You just aim for the next stable version release.
Looking back at the massive landscape of this deep dive, it is incredible how much philosophy can be extracted from such a niche scenario. I mean, we started by exploring the mind of a developer who approaches the physical world through the lens of fault-tolerant programming and open-source documentation.
And then we examined the evolutionary biology that turns the Golden Mbuna into such a volatile element and analyzed how placing 2 highly reactive nodes in a closed environment creates a catastrophic structural flaw.
We completely flipped the conventional wisdom of isolation on its head, exploring how adding more variables to a system like deploying a harem ratio to load balance the aggression actually diffuses the danger.
And we looked at the environmental mechanics of breaking line of sight to prevent biological burnout.
It is truly a masterclass in accepting the things you cannot change and aggressively engineering the environment around them until the system functions.
You know, Ang finishes part 211 with a very telling sign-off. He simply writes, "Let's see if these changes bring some peace to the tank in the coming days."
It is the ultimate tinker's mindset.
It really is. He knows he hasn't achieved perfection. He has just deployed a patch, and now he will monitor the logs. And I really want to leave you with a concept drawn straight from those telecom systems we discussed earlier.
Oh, the Erlang stuff.
Yeah. In the tech world, engineers don't measure success by a total absence of problems. They measure success through uptime, which is the percentage of time a system remains operational despite the constant barrage of errors, traffic spikes, and hardware failures.
Right.
So if you are facing a relentless recurring conflict in your own life right now, ask yourself, Are you exhausting your energy trying to permanently cure the problem, demanding a flawless utopian reality?
Or is it time to abandon the illusion of perfection, redesign your architecture to absorb the friction, and start optimizing for uptime?